Hello viewers, I'm Kausalya. Today we are going to solve problems related with Thevenin's theorem. The problem is use Thevenin's theorem, find the current through 5 plus J4 ohm in the figure. So here this is the given circuit diagram and we are expected to calculate the current that flows through this path, right? 5 plus J4 ohms. So the first step is we need to calculate the Thevenin. So what is the procedure? We have to remove this load resistance, right? So just draw a circuit diagram after removing the load resistance. You see here this is our circuit diagram, right? So the current from this voltage source flows like this, and at this node, right, at node C, the current gets divided into two, one as I1 and another one as I2. Right. So now we are going to calculate the current, that what is the values of I1 and I2. So how to calculate these two things? You see, when you look at this circuit, here this 10 ohm and 6 ohm are in series. Right. Similarly, 8 ohm and this 8 ohm are in series. So, and this 100 volt is impressed across this combination of resistors. Can you get what I am saying? This is the voltage source and this voltage source is across this combination as well as this combination, right? So we can easily calculate the value of I1 and I2. So I1 is nothing but V by, here these two are in series, therefore 10 plus 6, that gives the answer as 6.25 with an angle 0 degree. I am converting this into rectangular form. So 6.25 plus J0, right? And I2 is again the same 100 voltage is impressed across this series combination, therefore 100 divided by 8 plus 8. So when you solve, again that gives the same answer, right? Why we are having the same answer here? You see, because the resistor values are same. That is, when you combine these two, we are getting 16 ohms. And again, when you combine these two, again we are having the same 16 ohms. So whenever the resistor values are same, the current gets equally divided, right? Now the next thing is we are going to calculate this Thevenin's voltage, right? So for calculating Thevenin's voltage, either we can make use of these two resistors, that is voltage drop across these two resistors, or else these two resistors, right? It's up to what it depends upon, right? Either you can take this or you can take this. So here you see the current I1 flows in this way, whereas the current through this 8 ohm flows in an opposite way, right? And what is the current that flows through this 6 ohm? It is nothing but our I1 and here our I2. Right. So, you see here I am taking A as negative terminal, right? A with the potential of minus and B with the potential of plus. Therefore, minus 6 into I1 and here B is with plus, right? Therefore, plus 8 into I2. This is what I had written here. We know the values of I1 and I2. So, just substitute it and here the final answer is 12.5 volts, right? Or else if we take these two resistors, again the same thing. You see here A is with minus sign, right? Therefore minus 10 into I1 and here plus 8 into I2, right? So in either way the final answer remains the same. So here we are getting 12.5 volts. Even if you get voltage with a negative sign, no need to panic. Just we have to consider that we have to reverse the potential. Right, if we are getting the final answer as negative thing, you have to reverse the potential. That is, A should be taken plus and B should be taken minus. That's it. Right. Now we had calculated the value of Thevenin's voltage. The next thing is we have to proceed with R Thevenin. So how to find R Thevenin? Here the thing is we have to remove the voltage source. Right. So when you remove this voltage source, what happens? This voltage source is connected between the nodes C and D. So when you remove this, then C and D are connected by a simple wire or a conductor, right? Remaining the rest of the things, they remain the same. Therefore, this circuit diagram gets modified like this, right? That is, all the four resistors, they remain in their place, right? But C and D are get connected by means of a plain wire. So when you draw the circuit, it will be like this, right? So here again we need to calculate the R Thevenin. So how to calculate the R Thevenin here? You see our terminals are A and B, right? Between A and B, we are having our load resistance. So always keep this in mind. So this is a terminal and this is another terminal. So therefore, you see since here we are having a terminal, these two resistors are in parallel and again these two resistors are in parallel, right? And that combination comes in series. Can you get? Because only across this two junctions A and B we need to calculate, that is the load resistance is connected, right? Since load resistance is connected here, right? Here this 10 ohm and 6 ohm are said to be in parallel, okay? Just like this. And again this 8 ohm and this 8 ohm are in parallel because here we are having a terminal, right? That's the reason. So how to calculate the values? R1 into R2 by R1 plus R2 and here R1 into R2 by R1 plus R2. So when you simplify, again when you reduce these two resistors as a single resistor and these two resistors as a single resistor, what happens? Then that combination comes in series, right? So once you solve, here we are ending up with the final answer as 7.75 ohms. Right. Then the final step is we should draw the equivalent circuit and we should calculate the current that flows through the load resistor. So here this is the basic circuit, right? We should be having our Thevenin's voltage, Thevenin's resistance and a load impedance. So here according to the formula, you see what is how to calculate the load current? It is V Thevenin divided by R Thevenin plus ZL. So here V Thevenin, what is the value of V Thevenin? It is 12.5 and R Thevenin value is 7.75 and ZL. What is the value of ZL? Again when you look back in the problem, the value of ZL is 5 plus J4, right? So just substitute the values here. Once you substitute the values, here we are ending up with the final answer as 0.8925 minus J.280 amps, right? When you convert this into polar form, we are having our answer like this. So here in this, just you can write the values. Here it is 12.5 volt and here it is 7.75 ohm and here it is 5 plus J4 ohms, right? So here comes the end of this problem. We will move with the next one. The problem is find the Thevenin's equivalent circuit for the network given in the figure. So we have to draw Thevenin's equivalent circuit. So what are all the things we need? We should find Thevenin's voltage as well as Thevenin's impedance, right? Once you calculated that, then everything is over. So now here the first step is we need to calculate the Thevenin's voltage, right? So to calculate the Thevenin's voltage, you see the current from this voltage source, it reaches this place, right? And the entire current flows through this. It won't flow through this 3 ohm. Why? Because here it is open circuit, right? A current will never flow through a open circuit path. Therefore, the current that flows from this voltage source, okay, reaches here and again flows back like this and the circuit gets completed, right? So to calculate the current that flows through the circuit, we should consider only these three value of resistors and inductors and not this 3 ohm. Because the reason is current won't flow through the open circuit. So here just substitute the values. Here the voltage is 20 and the impedance is J4, 4 and again J4. So just substitute the values and once you solve, here we are ending up with the answer as 1 minus J2 amps. When you convert this in polar form, here we are getting the answer like this, right? Then the next thing is we need to calculate Thevenin's voltage, right? That is voltage across this terminal AB. So this voltage across this terminal AB is nothing but it is the voltage across this values of resistors and inductors, right? So we know the value of current, we know the value of impedances, so just substitute them. So V is nothing but I into Z. So this is the value of I and this is the value of Z. So once you substitute the values, we are ending up with the final answer like this, right? So this is rectangular form and this is in polar form. Then the next step is we need to calculate the Z Thevenin, right? So to calculate the Z Thevenin, the first thing is we should remove the voltage source, right? So here the voltage source is removed. The remaining things, they remain as such. And how to calculate the Z Thevenin? Z Thevenin should be always calculated from the terminal which is given, right? So from AB, we need to calculate the Z Thevenin. So here in this case, for example, I am telling when a current flows through this, you see the current gets divided into two. So when the current gets divided, what does that mean? These two branches are in parallel, right? And this combination comes in series with this 3 ohm, right? So here, that is what we have done. When these two things are in parallel, what is the formula? Z1 into Z2 divided by Z1 plus Z2. So here the Z1 is J4 and Z2 is 4 plus J4. So Z1 into Z2 divided by Z1 plus Z2. Right. And this combination comes in series with this 3 ohm. Therefore, here comes 3. Right. Once you solve and simplify, you see, don't go with LCM and all. You can just directly solve this division. Right. Once you solve, you are having answer like this. Then again, just add plus 3 to it. That's it. So here the value of Z Thevenin is 3.8 plus J 2.4. Right. The next thing is we need to draw the equivalent circuit. So an equivalent circuit of Thevenin should have a voltage source and a Z Thevenin and load resistance. Here the value of load resistance is not given. Therefore a voltage source and a Z Thevenin. That's it. This is your final Thevenin's equivalent circuit. Right. Now this problem gets over here. We will move with the next one. So determine Thevenin's equivalent across the terminals A and B. Right. So this is your terminal A and this is your terminal B. Here the circuit assumes what to say. It appears to be a little bit complicated, right? Because we need to calculate equivalent across the terminals A, B, but A is at one end and B is at other end, right? So don't worry. The thing is just we have to redraw the circuit, right? So when you redraw the circuit, what happens? You see this B side remains as such, right? Only we are redrawing this A part. So when you redraw this A part, what happens? You see, we are moving this A terminal upwards, right? When you move this A terminal upwards, you just here mark it as A. So to this A, what are all the resistors that are getting connected? One is 8 and another one is 12. So the same way 12 ohms and 8 ohms. And here as we are reversing the circuit, right? To this A part, plus is get connected, okay? Getting connected. Therefore, here we are writing plus and here we are writing minus, right? And the next thing is these two ends are shorted, right? So that is why you see here this end, okay? These two ends are shorted by a conductor, right? So this is the first step. You should do this carefully. Once this is done, then the problem is very easy, right? So after redrawing the circuit, you see in this circuit we are having a current source I1 and in this circuit I2. Again the direction of current flow is assumed from minus to plus and here also from minus to plus. That is why it is like this, right? The next thing is we are calculating the values of I1 and I2 because we need to calculate V Thevenin across this terminal, right? So how to calculate I1? You see, this is I1. We are having a voltage source and two resistors. So I is equal to V by R. So here the R is 8 plus 12. So the answer is 1 amps, right? Therefore, voltage across this 12 ohm resistor is, because here the current flowing is 1 amps. Therefore, 12 into 1, that gives 12 volts here. Right. The next thing is I2. Again the same way. We are having a voltage source and we are having these two resistors. So I2 is nothing but 10 divided by 9 plus 1. That gives the answer as 1 amps. Right. So this 1 amps current flows like this. Therefore voltage across this 1 ohm resistor is 1 into 1, which is nothing but 1 volt. Right. So here we need the voltage across these two terminals A and B. Right. So initially A is assumed with a negative sign and B is with a positive sign. Right. Therefore, here we are writing, you see, the voltage across 12 ohm, because this 12 ohm is connected with A and A is assumed to have negative potential. Therefore, minus of V12 plus V1. So when you substitute the values here, the final answer is minus 11 volts. Right. Then the next thing is we need to calculate the R Thevenin. So how to calculate the R Thevenin? We have to remove the voltage source. Right. When you remove the voltage source, you see our circuit looks like this. Right. So again you are looking back. Right. When you look back, you see these are the terminals. Right. Whenever you are having terminals, these two resistors are said to be parallelly connected, and again the same way these two resistors are said to be parallelly connected, and that combination comes in series. Right. Therefore 12 into 8 divided by 12 plus 8, and here 9 into 1 divided by 9 plus 1. So when you solve here, the final answer is 5.7 ohms. Now we are going to draw the Thevenin's equivalent circuit. So our Thevenin's equivalent circuit will be having a V Thevenin and Z Thevenin. Right. And across these terminals, AB remains the same because here no load resistance is given. Okay. Just they simply meant, that is, they simply ask us to draw the equivalent circuit. So this is our final equivalent circuit. Right. So here comes the end of this problem, even this video also. If you have any doubt, let me know in the comment section. Thank you.